Hello viewers, in today's class we are going to discuss yet another important and conceptual problem from definite integrals, right? And here we are going to discuss this problem where we have to find the greatest integer of this integral, right? So here this square bracket denotes the greatest integer function, and we have to find the greatest integer of the value of this integral, right, which is inside the symbol of greatest integer function, right? So here we have the integral from 0 to pi x, and we have mod of sine 2mx dx, right? And here m is some integer, right? So what we will do in this problem, first we'll find out the value of this integral, that is from 0 to pi x mod sine 2mx dx, right? So let us first denote this integral as I, right? And here we'll use some important properties of definite integrals to get the value of this integral, right? So here our integrand is x times mod of sine 2mx, right? So first what we will do, we'll make use of this property of definite integral, that is from 0 to a, and we have f of x dx. So this integral is equal to 0 to a, and we have f of a minus x dx, right? So this is an important property of definite integrals. So let us apply this property to this integral. So we'll get I, and we'll replace x by pi minus x, right? So we'll replace x by pi minus x, because here a is pi, right? So we have pi minus x, and this is mod of sine 2m, and here we have pi minus x, right? Now let us see this term, right? So here we have a mod of sine 2m times pi minus x can be written as sine 2m pi minus 2mx, right? Okay, now from trigonometry we know that the sine of 2n pi minus theta is equal to minus sine theta. So this is an important result from trigonometry. So here we have sine 2m pi minus 2mx. So theta is 2mx. So we can now write mod of negative of sine, and here we have 2mx due to this result, right? So theta is 2mx. So here we have mod of negative of sine 2mx, which is simply mod of sine 2mx, right? So now we can write this integral I as 0 to pi, and here we have pi minus x, and we have mod of sine 2mx, and here we have dx, right? So let us call this integral as 1, this is as 2, and we can further write this integral as 0 to pi. We have pi times the mod of sine 2mx, and here we have 0 to pi, and we have x times mod of sine 2mx dx, right? So we have written this integral as a difference of two integrals, right? And now this is our integral I, right? So we have I is equal to 0 to pi times sine 2mx, and here we have minus I, right? And taking this minus I to this side, we have 2I is equal to 0 to pi, and we have pi times mod of sine 2mx dx, right? So this integral I can be written as, taking this pi outside the integral, we have pi over 2 and 0 to pi mod of sine 2mx dx, right? So now we have obtained this expression, right? So let us apply the method of substitution to simplify this integral further, right? So what we will do, let us substitute t is equal to 2mx, right? So differentiating both sides, so we have dt over dx is equal to 2m. The derivative of x is 1. So we have dt over 2m is equal to dx, right? And we can change the limits of integration. So when x is 0, this is x. So when x is 0, so taking x is equal to 0 in this expression, so t is 0. And when x is pi, so we have t is equal to 2m pi, right? So now this integral reduces to this one, that is I is equal to pi over 2, and the limits of integration are from 0 to 2m pi, right? And here we have mod of sine t, and for dx we can write dt over 2m, right? So now uh, taking this 2m outside the integral, so we have pi over 4m, and here we have 0 to 2m pi and mod of sine t and dt, right? Now let us apply the next property, right? Now see, from the properties of periodic functions, we know that if we have an integral that is 0 to say nt f of x dx, right? So where n is some positive integer and t is the period of this function f of x, right? So when we have a periodic function f of x with period t where n is some positive integer, then this integral is n times 0 to t, and here we have f of x dx, right? And see, here this integral, that is this one, right? So this one is 0 to 2m pi and mod of sine t dt, right? And we know that mod of sine t is a periodic function, right? And the period of this function mod of sine t is pi, right? And here we have the term that is 2m, right? So 2m is some integer here. So we have due to this property n times 0 to t f of x dx, so here we have 2m multiplied 0 to pi, and we have mod of sine t dt, right? So now this integral I can be written as pi over 4m, and this integral can be written as 2m times 0 to pi, and here we have mod of sine t dt, right? So these two terms get cancelled, so here we have 2. So this is pi over 2, 0 to pi, and mod of sine t dt, right? So now we have I is equal to pi over 2 and 0 to pi, and here we have mod of sine t dt, right? Now see, if we take help of trigonometry, then we know that here we have 0, here we have pi over 2, this is pi, this is 3 pi over 2, and here we have 2 pi, right? And here the limits of integration are from 0 to pi, right? So it means we have to restrict ourselves in the first quadrant and second quadrant, right? And we know that in the first quadrant sine is positive, right? And in the second quadrant sine is also positive, right? So simply mod of sine t is equal to simply sine t, right? From the definition of mod function. So when t belongs to the interval 0 to pi, this function that is sine t is positive, right? So we can write mod of sine t simply sine t, right? So now here we have pi over 2 and 0 to pi, and here we have simply sine t and dt, right? And now this is a very simple integral. We have pi over 2, the integral of sine t is minus cos t, and the limits of integration are from 0 to pi, right? So we have we can take this negative sign outside, so we have minus pi over 2, and substituting the limits and taking the difference, we have cos pi minus cos of 0. So this is minus pi over 2, and cos pi is minus 1, cos 0 is 1, and this is minus pi over 2 times minus 2. So this is 2 and 2 get cancelled, and minus times minus, that is positive. So we are simply having the term pi, right? So the value of the integral I is pi, right? So viewers, we have obtained the value of this integral, which is inside the greatest integer function symbol, as pi, right? But we have to find the greatest integer of I, right? So we have greatest integer of pi, and the approximate value of pi is 3.14, right? And from the definition of greatest integer function, the greatest integer of 3.14 is equal to 3, right? So the value of this expression is equal to 3, right? So this is how we can solve this problem.